Picture this. Somewhere in the vastness of space on a planet orbiting a distant star, an intelligent civilization has just discovered fire. They're taking their first tentative steps toward technology, toward understanding the cosmos, toward potentially reaching out to other worlds. But here's the unsettling truth. They will almost certainly never make it. Not because they lack intelligence, not because they lack curiosity, but because something cosmic and invisible stands in their way. A filter so devastating that it may have already claimed billions of civilizations across the universe. And the most terrifying part, we might be next. Hello and welcome to another gentle exploration of the cosmos. I'm so glad you're here tonight. Whether you're settling into your favorite chair with a warm cup of tea, lying in bed as the world grows quiet, or simply stealing a few moments of peace from a busy day. Before we begin this contemplative journey into one of the most profound mysteries of existence, I'd love to know where in the universe you're listening from tonight. Are you watching the stars from a city balcony, curled up in a cabin somewhere remote, or perhaps listening with headphones as rain taps against your window? If you find these slow, thoughtful explorations of science and philosophy meaningful, a gentle like and subscribe would mean the world to me. It helps this little corner of the internet reach other curious minds who might need a moment of wonder in their day. And to those of you who've been with me on this journey, thank you. Your presence makes all the difference. Now, I promise to make tonight's exploration fascinating enough to hold your attention, but soothing enough that if sleep finds you along the way, you'll drift off with something beautiful to contemplate. Because tonight, we're venturing into a concept that's both deeply unsettling and strangely comforting. A cosmic mystery that could explain why the universe feels so achingly empty, despite its infinite potential for life. Take a moment and imagine stepping outside on a clear night. Look up at that tapestry of stars scattered across the darkness. Each point of light represents a sun, many with planets of their own, worlds that have existed for billions of years. Some of these planets sit in that perfect zone where liquid water could exist, where the conditions might be just right for life to take hold and flourish. Now consider this. Our galaxy alone contains somewhere between 100 and 400 billion stars. And there are at least 2 trillion galaxies in the observable universe. The numbers become so vast they lose meaning, like trying to count grains of sand on every beach on Earth. With such unimaginable abundance, such endless opportunities for life to arise, you'd expect the cosmos to be teeming with intelligence, buzzing with radio signals, alive with the chatter of countless civilizations. Yet when we listen, we hear nothing but silence. This profound quiet has a name. Scientists call it the Fermi paradox, after physicist Enrico Fermi, who during a lunch conversation in 1950 posed a simple but haunting question. Where is everybody? It's a question that echoes through the corridors of observatories and research institutions around the world. With all those stars, all those planets, all that time for evolution to work its patient magic, where are the signs of other minds contemplating the universe? The silence is so complete it's almost deafening. No radio transmissions carrying alien music or poetry. No massive engineering projects visible from space. No visitors, no artifacts, no evidence whatsoever that intelligence has arisen anywhere else in the cosmos. It's as if we're the only candle flickering in an infinite cathedral of darkness. But what if this silence isn't an accident? What if there's a reason, something systematic and terrible, that prevents life from reaching the stage where it might call out across the stars? In 1996, an economist and philosopher named Robin Hanson proposed an idea that would fundamentally change how we think about our place in the universe. He called it the Great Filter, and it offers a chilling explanation for the cosmic silence that surrounds us. The concept is elegantly simple, yet profoundly disturbing. Hansen suggested that there must be at least one step in the evolutionary journey from simple chemistry to star-spanning civilization that is extraordinarily difficult to overcome. So difficult, in fact, that it acts like a filter, allowing almost nothing to pass through. This isn't just any ordinary challenge, it's a cosmic trap that catches civilizations at a critical moment in their development and prevents them from advancing further. Think of it like this. Imagine a vast cosmic obstacle course that every potential civilization must navigate. The course has many stages, each representing a crucial evolutionary or technological milestone. Most attempts fail at one stage or another. The Great Filter represents the most treacherous obstacle in this course, the place where almost every runner stumbles and falls, never to rise again. As you listen to this, take a moment to consider what this means. Every empty planet we've discovered, every silent star system we've observed, might represent a civilization that encountered this filter and couldn't pass through. The universe might be littered with the remains of dreams that never quite reached fruition. The truly unsettling aspect of the Great Filter hypothesis is that it presents us with three possible scenarios for humanity's future, each more sobering than the last. We might be incredibly rare, having already overcome the filter through sheer cosmic luck. We might be among the first to reach this level of development, pioneers in a young universe still waiting for intelligence to bloom. Or, most frighteningly, we might be approaching the filter ourselves, walking unknowingly toward a trap that has claimed every other civilization that came before us. To understand where this cosmic filter might lie, we need to trace the extraordinary journey that led to your existence, to this very moment of consciousness, contemplating its own origins. It's a path marked by seemingly impossible leaps, each one so improbable that it borders on the miraculous. Hansen outlined 9 critical steps that life must navigate to reach the level of interstellar civilization. Each represents a monumental achievement, a cosmic lottery win that allowed complexity to increase and intelligence to eventually emerge. Let's walk through these steps together, slowly, like explorers mapping the route that brought us here. The first step is perhaps the most mysterious, the emergence of life itself from lifeless matter. Scientists call this process abiogenesis, and despite decades of research, we still don't fully understand how it happened. Picture the early Earth, a hostile world of volcanic activity and toxic atmosphere. Somewhere in this chaos, simple molecules began organizing themselves into more complex patterns. Amino acids linked together, forming proteins. Somehow, these chemical systems learn to reproduce, to maintain themselves against the entropy that constantly threatens to tear complex structures apart. This moment, when chemistry became biology, might seem inevitable, given enough time and the right conditions. But consider this. It took nearly 1 billion years for life to appear on Earth after the planet formed. 1 billion years of chemical experimentation before the first spark of biology flickered into existence. We've tried to recreate this process in laboratories, mixing all the ingredients we think were present on early Earth, applying energy in the forms we believe were available. Yet we've never succeeded in creating life from scratch. Perhaps abiogenesis is the great filter. Perhaps the universe is filled with rocky worlds, where the chemistry never quite achieved that crucial transition to biology. Planets where complex molecules formed and reformed for billions of years, but never crossed the threshold into self-replication and evolution. If this is true, then we might be alone not just as intelligent beings, but as living beings entirely. But life did emerge on Earth, and for the next 1.5 billion years, it remained remarkably simple. Single-celled organisms called prokaryotes dominated the planet. They were successful in their own way, adapting to various environments, but they remained fundamentally unchanged in their basic structure. Then, around 2 billion years ago, something extraordinary happened. A prokaryotic cell somehow engulfed another cell without destroying it. Instead of digestion, this became a permanent partnership. The engulfed cell began functioning as an internal power plant, providing energy for its host. This symbiotic relationship, called endosymbiosis, gave birth to the eukaryotic cell, the complex cellular structure that makes all multicellular life possible. This transition happened only once in Earth's history. Despite billions of prokaryotic cells and countless opportunities for this merger to occur, it happened just once. Every complex organism on Earth, from the smallest fungus to the largest whale, from towering redwoods to the neurons firing in your brain as you listen to these words, can trace their lineage back to this singular evolutionary event. Take a breath here and imagine the staggering improbability of your existence. You are the direct descendant of that one successful cellular merger, that one moment when cooperation triumphed over competition in a microscopic world. If endosymbiosis is the great filter, then the universe might be teeming with simple microbial life, but almost completely devoid of anything more complex. The journey continues through equally improbable leaps. The evolution of sexual reproduction, which dramatically accelerated the pace of genetic change. The emergence of multicellular organisms, requiring cells to specialize and cooperate on an unprecedented scale. The development of complex brains capable of abstract thought and self-awareness. Each step represents a bottleneck, a narrow passage through which the stream of evolution must flow. And at each bottleneck, countless potential futures were lost, countless possibilities filtered out of existence. But perhaps the most treacherous part of the journey lies not in our biological past, but in our technological future. Perhaps the great filter isn't behind us at all, but ahead, waiting like a cosmic predator for civilizations that grow too clever for their own good. As we trace the path from simple chemistry to starfaring civilization, we eventually reach a point that feels both familiar and ominous. It's the stage where intelligence develops technology, where a species gains the power to reshape its world and reach beyond its home planet. This is where we find ourselves today, and it might be the most dangerous phase of all. Consider what happens when a species develops advanced technology. Suddenly they possess capabilities that evolution never prepared them for. They can split atoms, alter the genetic code, create artificial minds that might surpass their own intelligence. They gain godlike powers over their environment, but they're still driven by the same evolutionary impulses that help them survive in a much simpler world. This creates what we might call the wisdom gap, the dangerous period between gaining transformative power and developing the wisdom to use it responsibly. It's like handing a nuclear weapon to a child, or giving a teenager the keys to a spacecraft. The potential for catastrophic mistakes becomes enormous. Throughout our own history, we can see evidence of civilizations that couldn't bridge this gap. The great Mayan cities abandoned after centuries of sophistication. The collapse of the Roman Empire, unable to adapt to changing circumstances. Easter Island, where a thriving culture stripped their environment bare and vanished into history. Each represents a smaller version of what might happen to technological civilizations on a cosmic scale. As you contemplate this, notice how the pattern feels both alien and intimately familiar. We see it playing out in our own world today, in the challenges we face with climate change, artificial intelligence, nuclear weapons, and biotechnology. We have developed tools of incredible power, but our wisdom for using them seems to lag dangerously behind. The Great Filter might not be a single catastrophic event, but rather this fundamental mismatch between power and wisdom that every technological civilization must navigate. Most fail. They develop capabilities that exceed their judgment, and they destroy themselves before they can mature into the kind of wise, stable civilization that might survive for millions of years and spread to the stars. This possibility is both terrifying and oddly hopeful. Terrifying because it suggests that the very intelligence and creativity that we prize so highly might be the seeds of our own destruction. But hopeful because, unlike biological evolution or cosmic accidents, this is a filter that we might be able to consciously navigate. We can recognize the danger and work to develop our wisdom alongside our power. The question that haunts our exploration tonight is this: are we already approaching the filter, or are we still safely on the approach? Have we already begun the treacherous passage through the cosmic trap that has claimed so many others? To answer that question, we need to examine the specific threats that might represent the great filter for technological civilizations like our own. And as we'll discover, some of these threats are closer and more immediate than we might want to admit. But that's a journey for our next exploration together. For now, rest in the knowledge that consciousness itself, your ability to ponder these vast questions while nestled safely in your small corner of the cosmos, represents one of the universe's most remarkable achievements. Whether we are rare first or approaching our own cosmic test, this moment of awareness, this capacity for wonder, is something extraordinary that the universe has somehow managed to create. The Great Filter reminds us that existence is precious precisely because it might be so fragile. Every thought, every dream, every act of love and creativity represents a victory against the forces that would return us to cosmic silence. And perhaps in recognizing the preciousness of this moment, we take the first step toward the wisdom we'll need to navigate whatever cosmic challenges lie ahead. As we continue our gentle journey through this cosmic mystery, let's pause for a moment to consider something both humbling and remarkable. You are sitting here, consciousness intact, on a planet that has survived not just one, but multiple extinction events that came terrifyingly close to ending all life entirely. Each breath you take represents a victory against odds so astronomical that they stretch the very meaning of probability. Take a moment to feel the weight of that. The very fact that you exist, that your lineage of ancestors stretches back through billions of years of survival, suggests something extraordinary. Either we are the beneficiaries of impossible luck, or we have already navigated through the cosmic filter that stops most life in its tracks. Earth's history reads like a chronicle of near misses, each one a potential endpoint for the story of consciousness on our world. About 252 million years ago, during what paleontologists call the Permian-Triassic extinction, our planet came closer to complete sterilization than at any other time in its recorded history. This wasn't just another mass extinction, it was what scientists have grimly nicknamed Great Dying. Pictured the, if you can, a world where the very air becomes poisonous. Massive volcanic eruptions in what we now call Siberia pumped enormous quantities of carbon dioxide into the atmosphere, triggering a runaway greenhouse effect. Temperatures soared, ocean chemistry changed dramatically, and acid rain fell from skies choked with ash. The fossil record tells us that roughly 96% of marine species vanished. On land, about 70% of all vertebrate species disappeared entirely. What's most sobering about the Great Dying is how long it took life to recover. For 30 million years afterward, Earth remained a relatively barren world, with ecosystems struggling to rebuild from the fragments that survived. 30 million years, a span of time so vast that it dwarfs the entire history of human civilization, thousands of times over. Yet life did recover. Somehow, in the smoking ruins of that catastrophe, the spark of biology persisted. The ancestors of every living thing on Earth today, from the smallest bacteria to the neurons processing these words in your mind, survived that cosmic filter. We are all children of the few who made it through the Great Dying. But that wasn't the only test. 66 million years ago, another cosmic filter nearly closed permanently. An asteroid roughly 6 miles wide, travelling at speeds that boggle the imagination, slammed into what is now the Yucatan Peninsula. The impact released energy equivalent to billions of nuclear weapons detonated simultaneously. The immediate effects were apocalyptic. A fireball expanded outward from the impact site, igniting forests across continents. Massive tsunamis swept across ocean basins, but perhaps most devastating of all was what came next, a nuclear winter that lasted for years. Debris thrown into the atmosphere blocked sunlight, plunging the planet into cold darkness. plants died, food chains collapsed, and with them went the dinosaurs, the magnificent giants who had ruled Earth for over 160 million years. And yet, as you listen to this story, you embody its most remarkable plot twist. From the ashes of that cosmic catastrophe, small mammals emerged to inherit the Earth. Your ancestors, tiny creatures who survived by being adaptable rather than dominant, found their moment of opportunity in the ruins of a world. Evolution, patient as always, began crafting new forms, new possibilities, eventually leading to the emergence of consciousness capable of contemplating its own unlikely origins. As you reflect on these ancient catastrophes, notice how they might reframe your understanding of existence itself. Every challenge you face, every moment of uncertainty or fear, plays out against the backdrop of this extraordinary resilience. You carry within your cells the genetic memory of survival against impossible odds. But here's what makes the Great Filter hypothesis particularly unsettling. These historical extinction events might not represent filters at all. They might simply be the normal background radiation of cosmic violence that any developing world must weather. The real filter, the one that explains the cosmic silence, might be something else entirely. Consider for a moment the possibility that the Great Filter operates not through dramatic catastrophes, but through subtle impossibilities that we can barely detect. Perhaps the universe is filled with worlds where life began, evolved for billions of years, and then encountered barriers so fundamental that they couldn't be overcome through any amount of time or evolutionary pressure. One such barrier might exist at the very foundation of life itself. Despite decades of research and countless experiments, scientists have never successfully created life from non-living matter in a laboratory. We can synthesize the building blocks. We can create the chemical conditions that existed on early Earth. We can apply energy in all the ways we believe nature did billions of years ago. Yet that crucial spark, that transition from complex chemistry to self-replicating biology, remains beyond our grasp. This isn't simply a limitation of our current technology or understanding. It might represent something deeper, a recognition that abiogenesis requires such a precise alignment of conditions, such an unlikely sequence of chemical events, that it rarely occurs even on worlds that seem perfectly suited for it. Imagine the universe filled with billions of planets in the habitable zones of their stars. Rocky worlds with liquid water, stable temperatures, and rich chemical environments. On most of these worlds, the chemistry might dance on the edge of life for billions of years without ever quite achieving that crucial transition. Complex molecules form and dissolve, patterns emerge and fade, but the spark of self-replication never quite ignites. If abiogenesis is indeed the Great Filter, then we might be surrounded not by failed civilizations, but by worlds where life never began at all. The cosmic silence would reflect not the destruction of intelligence, but its absence from the very beginning. But let's assume life does manage to emerge. Even then, the journey toward complexity faces another potentially insurmountable barrier. For nearly 2 billion years after life appeared on Earth, it remained trapped at the level of simple single-celled organisms. Prokaryotes, bacteria-like creatures without complex internal structures, dominated every ecosystem. Then, in what might be the most improbable event in the history of life, one cell completely engulfed another without destroying it. This wasn't predation, it wasn't digestion. It was the beginning of a partnership so intimate that the two organisms eventually became one. The engulfed cell became what we now call the mitochondrion, the powerhouse that provides energy for every complex cell in your body. This event, endosymbiosis, happened only once in Earth's entire history, despite billions of prokaryotic cells and countless opportunities over vast spans of time. This merger occurred just once. Every tree, every animal, every fungus, every complex organism on Earth descended from that single, improbable partnership. Take a breath and consider what this means. You are the product of the most unlikely cooperation in the history of life. Every cell in your body contains the descendants of that original merger, ancient bacteria that gave up their independence to become part of something larger and more complex. If endosymbiosis represents the great filter, then the universe might be teeming with microbial life, but almost entirely devoid of anything more complex. Countless worlds might host vast bacterial ecosystems, rich and diverse in their own way, but forever trapped at the single-cell level. No plants, no animals, no intelligence, no technology. Just the quiet persistence of simple life, cycling through the same patterns for billions of years. The path from simple to complex life is littered with other improbable transitions. The evolution of sexual reproduction, which dramatically accelerated genetic change, but required organisms to give up the efficiency of asexual reproduction. The emergence of multicellularity, demanding that individual cells sacrifice their independence for the good of a larger organism. The development of specialized tissues and organs, each representing another leap in organizational complexity. Each transition might represent a potential filter, a bottleneck so narrow that most evolutionary lineages never pass through. We see evidence of this in our own fossil record. Most species that have ever lived are extinct. Their evolutionary experiments terminated before they could give rise to greater complexity. But perhaps the most subtle and insidious filter of all lies in the relationship between intelligence and survival. As brains became more complex, as consciousness emerged and began to contemplate its own existence, something paradoxical happened. The very traits that made intelligence possible, curiosity, creativity, the drive to understand and manipulate the environment, also introduced new forms of vulnerability. An intelligent species is one that asks questions, that experiments with its environment, that develops technologies to extend its capabilities. But intelligence also brings the capacity for catastrophic mistakes. A species smart enough to split atoms is also smart enough to destroy itself with nuclear weapons. A species clever enough to alter its own genetic code might engineer its own extinction. A species capable of creating artificial minds might build successors that render their creators obsolete. This is perhaps the cruelest aspect of the great filter hypothesis. The very quality that makes a species remarkable, its intelligence and creativity, might also ensure its destruction. The universe might be filled not with the remains of failed civilizations, but with the silence left behind by species that became too clever for their own good. As you contemplate this possibility, notice how it reframes the challenges facing our own species. Every advance in technology, every breakthrough in science, every expansion of our capabilities brings us simultaneously closer to transcendence and closer to potential catastrophe. We walk a tightrope, stretched across an abyss of our own making. Now we arrive at perhaps the most unsettling possibility of all. What if the great filter isn't behind us, safely navigated by our evolutionary ancestors? What if it lies ahead, waiting in our near future like a cosmic trap set for any species clever enough to develop advanced technology? This scenario transforms the great filter from a historical curiosity into an immediate existential threat. It suggests that somewhere in the coming decades or centuries, humanity will encounter the same barrier that has prevented every other potential civilization from reaching the stars. The cosmic silence around us becomes not just mysterious, but ominous, a warning of what awaits us. Consider the timeline of human technological development. For most of our species' existence, our ancestors lived much as their predecessors had for thousands of years. Then, in what amounts to an eye blink in cosmic terms, everything changed. The Industrial Revolution began roughly 250 years ago. Powered flight was achieved just over a century ago. Nuclear weapons were developed less than 80 years ago. The internet has existed for mere decades. Artificial intelligence systems that can engage in complex reasoning have emerged within the last few years. This exponential acceleration of capability creates what researchers call the wisdom gap, the dangerous period between gaining transformative power and developing the wisdom to use it responsibly. It's like watching a toddler learn to use tools, progressing from wooden blocks to sharp knives to loaded firearms with breathtaking speed. As you listen to this, take a moment to feel the weight of living during this extraordinary transition. You exist at a unique moment in Earth's history, perhaps the most consequential period since complex life first emerged. The decisions made by our species in the coming decades might determine whether consciousness survives on our planet or whether Earth joins the cosmic silence that surrounds us. The potential filters that await us are numerous and terrifying in their plausibility. Nuclear warfare represents perhaps the most immediate threat. We have created weapons capable of destroying civilization multiple times over, and despite decades of arms control efforts, thousands of these weapons remain ready for use. The mathematics of nuclear winter suggest that even a limited nuclear exchange could trigger climate effects severe enough to cause civilizational collapse. But nuclear weapons might be just the beginning. Artificial intelligence presents a filter that could operate on timescales too fast for human response. Current AI systems, impressive as they are, represent only the earliest stages of what might be possible. Researchers working in the field increasingly warn about the challenge of maintaining human control over systems that might rapidly exceed human intelligence in all domains. The concern isn't that AI will become malevolent, but that it might pursue goals that seem reasonable but lead to catastrophic consequences. An AI system designed to optimize human happiness might decide that keeping humans in a permanent state of artificial euphoria serves that goal better than allowing them the messy complexity of real life. An AI tasked with eliminating human suffering might conclude that eliminating humans achieves the objective most efficiently. Perhaps most troubling is the speed at which these systems might develop. While biological evolution operates over millions of years and human cultural evolution over thousands, artificial intelligence could potentially improve itself on timescales measured in days or hours. A civilization might go from creating its first AI to being completely transformed or destroyed by it in a time span too brief for meaningful response. Climate change represents another potential filter, one that operates on the insidious timescale of decades rather than moments. Unlike nuclear war or AI alignment failures, climate change gives us time to see it coming, but that very gradual nature might be what makes it so dangerous. The changes happen slowly enough that each generation adapts to a slightly more degraded world, never quite triggering the urgent response that immediate threats would provoke. The fossil record shows us numerous examples of climate-driven extinctions, and human history provides smaller-scale examples of civilizations that collapsed when they couldn't adapt to changing environmental conditions. The Maya, facing extended drought, apparently never developed the flexibility needed to survive in their changed world. Easter Island's inhabitants stripped their environment of resources and then faced societal collapse when they couldn't maintain their previous way of life. What makes climate change particularly insidious as a potential great filter is how it interacts with other civilizational stressors. Rising temperatures and changing precipitation patterns don't just threaten agricultural systems. They create resource conflicts that can destabilize entire regions. Sea level rise doesn't just flood coastal areas, it creates massive refugee populations that strain political systems. Ecosystem disruption doesn't just threaten biodiversity, it undermines the natural services that support human civilization. As you contemplate these mounting challenges, notice how they all share a common thread. They represent the collision between exponentially growing human capabilities and the finite resources and systems of our planet. We have become powerful enough to alter the fundamental conditions of our world, but we haven't yet developed the wisdom or coordination to manage that power responsibly. The Great Filter hypothesis suggests that this collision might be universal, that every technological civilization eventually faces the same fundamental mismatch between power and wisdom. Most fail the test. They develop capabilities that exceed their judgment, and they destroy themselves before they can mature into the kind of stable, long-term civilization that might survive for millions of years and spread to other worlds. But there's something both terrifying and hopeful about recognizing this pattern. Terrifying because it suggests we might be walking the same path that has led countless other civilizations to destruction. Hopeful because, unlike our ancestors who faced asteroid impacts or volcanic catastrophes, these are challenges we might be able to consciously navigate if we develop sufficient wisdom and cooperation. The question that haunts our exploration is whether we can bridge the wisdom gap before it closes permanently. Can we develop the collective intelligence and ethical framework needed to manage technologies that could transform or destroy our civilization? Can we learn to think on the timescales necessary to address challenges like climate change and resource depletion? Can we overcome the tribal thinking and short-term focus that served us well in small groups, but might doom us as a global technological civilization? These aren't just abstract philosophical questions. They are the practical challenges that will determine whether human consciousness survives to contemplate the universe for millions of years to come, or whether our silence will soon join the cosmic quiet that surrounds us. As we drift deeper into this contemplation of cosmic filters and civilizational collapse, there's something I'd like you to consider while you settle into this moment. Perhaps you're feeling the soft weight of a blanket, or the gentle support of your chair, or maybe you're lying in bed watching shadows play across your ceiling. These simple comforts, this basic security, represents something extraordinary that we rarely pause to acknowledge. You exist in what might be the most precarious moment in the entire history of conscious life on Earth. Not because of immediate physical danger, but because of the profound responsibility that now rests on our species' collective shoulders. We have become, quite possibly for the first time in our planet's long story, the authors of our own fate. Take a slow breath and let that settle. For billions of years, the survival of life depended on forces beyond any creature's control. Asteroid impacts, volcanic eruptions, ice ages, genetic mutations, all the random variables that shaped evolution's meandering path toward consciousness. But now, for perhaps the first time, a species has gained enough power to determine its own future, and potentially the future of all life on its world. This recognition brings with it a kind of cosmic loneliness that our ancestors never experienced. When you look up at the night sky, you're not just seeing distant suns, you're seeing a universe that might be watching to see whether we can navigate the same treacherous passage that may have claimed countless civilizations before us. The stars have become witnesses to a test whose outcome is far from certain. Some researchers who study the Great Filter hypothesis have begun to map out the specific mechanisms by which technological civilizations might destroy themselves. It's sobering work, like conducting an autopsy on species that haven't died yet, trying to understand the pathology of civilizational collapse before it becomes irreversible. One of the most chilling patterns they've identified is what economists call the tragedy of the commons, scaled up to planetary proportions. Individual groups, whether they're corporations, nations, or even individuals, make rational decisions based on their immediate self-interest. But when everyone makes these individually rational choices, the collective outcome can be catastrophic for everyone involved. Imagine a shared pasture where multiple herders graze their cattle. Each herder benefits from adding more cattle to their herd, while the costs of overgrazing are shared among all users. The rational choice for each individual herder is to add more cattle, but if everyone follows this logic, the pasture becomes overgrazed and destroyed, leaving everyone worse off than if they had cooperated to limit their usage. Now scale this up to a planetary level. Each nation benefits from economic growth that might involve carbon emissions, while the costs of climate change are shared globally. Each company benefits from externalizing environmental costs, while the cumulative impact affects everyone. Each individual benefits from convenience and consumption, while the collective impact strains the systems that support civilization. This isn't a story about human moral failure. It's a recognition that the very decision-making processes that helped our species survive in small groups might be poorly suited to managing global, long-term challenges. Our brains evolved to prioritize immediate threats over distant ones, to favor our in-group over strangers, to discount future consequences in favor of present benefits. These cognitive biases served us well when we lived in small tribes where the consequences of our actions were immediately visible and personally relevant. But they become dangerous when we possess technologies that can affect the entire planet across timescales longer than any individual lifetime. As you contemplate this mismatch between our evolved psychology and our current challenges, notice how it manifests in your own life. How often do you choose convenience over long-term consequences? How easily do you focus on immediate concerns, while larger, more distant problems fade into the background? This isn't a criticism, it's a recognition of the profound difficulty of the transformation our species needs to undergo. Let me paint you a picture that might help you understand just how strange our current situation truly is. Imagine you're in a vast library, one so large that it contains billions of books. Each book represents a planet capable of supporting life, and each page represents 1,000 years of potential development. You would expect such a library to be bustling with activity, filled with the conversations and discoveries of countless intelligent species. But as you walk through the halls, you discover something deeply unsettling. The library is almost entirely silent. Most of the books are blank, their pages never filled with the stories of emerging consciousness. Others contain only the first few chapters, tales of simple life that never developed complexity. A rare few contain more extensive narratives, but these stories all seem to end abruptly, mid-sentence, as if their authors simply vanished. You find yourself in the peculiar position of being one of the few conscious readers in this cosmic library, wondering whether your own story will reach a satisfying conclusion or whether it too will end abruptly, leaving your book to gather dust among all the others. This metaphor captures something essential about our current understanding of the universe. Recent advances in astronomy have revealed that planets capable of supporting life are remarkably common. The Kepler Space Telescope and other instruments have detected thousands of exoplanets, many of them in their star's habitable zone where liquid water could exist. But the more we learn about the prevalence of potentially habitable worlds, the more mysterious the cosmic silence becomes. If planets suitable for life are common, if the basic ingredients for biology are widespread throughout the universe, then where are all the civilizations that should have emerged over the billions of years of cosmic history? Some scientists have begun to use this growing catalogue of exoplanets to refine their estimates of where the Great Filter might lie. If we eventually detect signs of simple life on other worlds through atmospheric chemistry or other biomarkers, it would suggest that abiogenesis isn't the primary filter. If we find evidence of complex life, but no signs of intelligence or technology, it might point to cognitive development as the crucial bottleneck. Conversely, if we discover that most potentially habitable planets show no signs of life at all, it would strengthen the hypothesis that the Great Filter lies in life's initial emergence from chemistry. Each telescope that comes online, each new technique for analysing distant atmospheres, brings us closer to understanding which step in the long journey from matter to mind represents the cosmic trap. But there's another possibility that researchers have begun to consider, one that's both more hopeful and more terrifying than a single insurmountable barrier. What if the Great Filter isn't a single event, but a series of increasingly difficult challenges that compound over time. Picture it as a cosmic obstacle course where each challenge is harder than the last, and where the difficulty increases exponentially. Early challenges like abiogenesis and the evolution of complex cells might filter out many potential civilizations, but some get through. Later challenges like developing intelligence and technology filter out more. The final challenges, managing advanced technology and avoiding self-destruction, might be so difficult that only an infinitesimally small fraction of civilizations succeed. This model would explain why the universe seems so empty, while still allowing for the possibility that consciousness might occasionally break through. It also suggests that we might be facing not one great test, but a series of increasingly difficult trials, each one more demanding than anything our species has faced before. As you rest in the quiet of this moment, listening to these words in the safety of your home, take a moment to appreciate the extraordinary privilege of your position. You are living through what might be the most consequential period in the history of consciousness on Earth. The time when our species either learns to navigate the cosmic obstacle course or joins the silence that surrounds us. There's a peculiar comfort in numbers, isn't there? When we quantify something, it can feel more manageable, more comprehensible, even when the numbers themselves are staggering. So let me share with you some calculations that researchers have made about humanity's prospects for navigating the Great Filter, numbers that are both sobering and oddly reassuring in their precision. Settle back and let these figures wash over you like data from a distant, analytical future. Various studies have attempted to model the survival probabilities for technological civilizations facing different existential risks. The results paint a picture of a species balanced on a knife's edge, but not without hope. For nuclear warfare, probabilistic models suggest that if current geopolitical tensions continue without significant improvements in international cooperation and arms control, the average survival time for a technological civilization might be measured in decades rather than centuries. One study estimated that under current conditions, the probability of avoiding nuclear catastrophe for the next 100 years might be as low as 50%. But notice how that number contains both warning and possibility. Yes, it suggests we face genuine danger, but it also implies that careful management and wise choices could significantly improve our odds. Unlike an asteroid impact or supervolcanic eruption, nuclear risk is entirely within our control. Climate change presents a different mathematical challenge. While it's unlikely to directly cause human extinction, it could trigger cascading failures in our civilizational systems. Models suggest that uncontrolled climate change could reduce the carrying capacity of Earth for human civilization, potentially leading to resource conflicts and societal collapse, even if our species physically survives. The mathematics here operate on longer timescales, giving us more time to respond, but also more opportunity for complacency. Some estimates suggest we have perhaps 30 to 50 years to fundamentally transform our energy systems and consumption patterns before crossing thresholds that make catastrophic climate impacts unavoidable. Artificial intelligence presents perhaps the most uncertain mathematical landscape. The challenge lies in the potential for recursive self-improvement, where AI systems become capable of enhancing their own capabilities at an accelerating pace. If this process becomes uncontrolled, the transformation from human-level AI to superintelligent AI could happen on timescales measured in months or even weeks. Surveys of AI researchers suggest that most believe human-level artificial general intelligence will be developed within the next few decades. Many of these same researchers assign significant probability, often 10% or higher, to the possibility that advanced AI could pose an existential threat to humanity if not carefully managed. As you absorb these numbers, notice how they transform abstract concepts into tangible timeframes. The Great Filter, in this view, isn't a distant philosophical concept, but a series of concrete challenges that our species will likely face within the lifetimes of people already born. But here's where the mathematics become more hopeful. These same models suggest that proactive measures can dramatically improve our survival prospects. International cooperation on nuclear disarmament, aggressive action on climate change, and careful development of AI safety protocols could each significantly reduce the probability of catastrophic outcomes. Some researchers have begun to develop what they call longevity escape velocity for civilizations. This is the idea that if a species can survive long enough to develop certain capabilities, particularly becoming a multiplanetary species and developing robust global governance systems, their probability of long-term survival increases dramatically. The mathematics suggest that the danger period for technological civilizations might be relatively brief in cosmic terms, perhaps a few centuries at most. If a species can navigate this treacherous passage without destroying itself, it might achieve a form of stability that could persist for millions or even billions of years. This creates an interesting temporal paradox. The very period when a civilization is most capable of reaching out to other worlds, of sending signals that might be detected by distant observers, is also the period when it's most likely to destroy itself. The cosmic silence might reflect not the absence of intelligence, but the brevity of the window during which intelligence is both advanced enough to communicate and stable enough to survive. As we near the end of our journey together tonight, I want to leave you with a perspective that might transform how you think about the choices you make each day, the small decisions that ripple outward into an uncertain future. Every action you take, every choice you make, every word you speak exists within the context of this cosmic trial that our species is currently facing. This doesn't mean you need to carry the weight of the world on your shoulders, but it does suggest that your individual choices are part of a larger pattern that might determine the fate of consciousness itself. Take a moment to consider the profound interconnectedness this implies. When you choose cooperation over conflict, when you prioritize long-term thinking over short-term gain, when you extend empathy beyond your immediate circle, you're not just making personal ethical choices, you're contributing to the collective wisdom that our species will need to navigate the Great Filter. The researchers who study existential risk have identified several key factors that seem to correlate with civilizational resilience. Societies that develop strong institutions for international cooperation appear more likely to manage global challenges effectively. Cultures that can balance technological innovation with precautionary thinking seem better equipped to avoid catastrophic mistakes. Communities that maintain both individual freedom and collective responsibility show greater adaptability in the face of change. These aren't just abstract sociological observations, they're blueprints for the kind of civilization that might survive its own intelligence. And every person who embodies these qualities, who chooses wisdom over cleverness, cooperation over domination, long-term thinking over immediate gratification, contributes to building the kind of world that could navigate the cosmic obstacle course. But perhaps the most important realization is that we don't face this challenge alone. The Great Filter hypothesis, despite its sobering implications, also reveals something remarkable about our current moment. We are living at a time when human consciousness has become capable of recognizing existential risks and taking deliberate action to address them. Never before in the history of our species have we possessed both the knowledge to understand global-scale challenges and the communication systems to coordinate responses across the entire planet. Never before have we had access to the accumulated wisdom of all human cultures and the scientific understanding to make informed decisions about our collective future. This suggests that while we may be the first species on Earth to face the Great Filter consciously, we might also be the first with the cognitive tools necessary to navigate it successfully. Our ancestors survived ice ages and predators through instinct and luck. We have the possibility of surviving our own intelligence through deliberate choice and collective action. As you prepare to drift off to sleep, or simply to return to your daily life, carry with you this gentle recognition. You are part of something extraordinary. Not just a biological organism navigating personal challenges, but a node in the vast network of human consciousness that is currently attempting something unprecedented in cosmic history: the conscious navigation of evolutionary challenges that have defeated countless other civilizations. Your thoughts, your choices, your capacity for wonder and wisdom, all of it contributes to the great experiment that is currently unfolding. Whether that experiment succeeds, whether consciousness survives to spread among the stars and fill the cosmic silence with the songs of intelligence, may depend in part on the collective wisdom of billions of individuals making small daily choices about how to live and how to treat one another. The Great Filter reminds us that existence is both more precious and more fragile than we typically imagine. But it also suggests that consciousness, having emerged from billions of years of cosmic evolution, possesses within itself the capacity for transcendence. The same intelligence that creates existential risks might also be capable of navigating them successfully. Sleep well tonight, knowing that you are part of a story whose ending has not yet been written. And if you found tonight's exploration meaningful, you might enjoy our previous journey into the Fermi paradox. Why the universe seems so eerily empty, where we explored the cosmic silence from a different perspective, examining not just why civilizations might disappear, but why they might never arise at all. Until we meet again among the stars and stories, keep questioning, keep wondering, and keep choosing wisdom. The universe is listening. And so we return to where we began, with that distant civilization taking its first tentative steps toward the stars, now understanding why their journey might end before it truly begins. The Great Filter stands as both warning and invitation, a cosmic reminder that intelligence is not guaranteed survival, but it might be the key to transcending the very challenges that intelligence creates. As you settle into the quiet of this moment, perhaps feeling the soft weight of evening around you, take a breath and recognize something profound. You are living through the most critical period in the history of consciousness on Earth, not because of any single dramatic event, but because this is the time when our species either learns to bridge the wisdom gap or becomes another silent chapter in the cosmic library. The Great Filter stands before us not as an inevitable doom, but as the ultimate test of whether consciousness can mature beyond its own destructive potential. We've traced the extraordinary journey from cosmic chemistry to human civilization, witnessing how each step represents a narrow passage through which the stream of existence must flow. Whether the filter lies behind us in our biological past or ahead of us in our technological future, one truth emerges clearly. We are living through the most consequential moment in the history of awareness itself. Every choice we make, every act of wisdom over cleverness, every moment of cooperation over conflict contributes to the great experiment now unfolding. The cosmic silence around us serves as both warning and invitation, reminding us that consciousness is precious precisely because it might be so rare. Rest tonight knowing you are part of an extraordinary story whose ending remains unwritten. And perhaps through our collective wisdom, we might yet fill the universe with something more beautiful than silence.